Once you have computed the Pearson-R correlation coefficient, you will next get introduced to the Pearson-R table and learn how to compare the Pearson-R you calculate with a critical table value to determine if the relationship is statistically significant. That process will quantify statistical significance. However, the customary next step is to calculate the coefficient of determination, for which the symbol is r squared. This r squared is different than the one you learned to calculate for t-tests. To calculate this r squared, one simply squares the Pearson-R that you calculated using the Pearson-R formula, and then convert the result of that into a percentage. The coefficient of determination measures practical significance, and it gives you the percent of variability in the X dataset that can be attributed to the variability in the Y dataset. The four-step hypothesis testing process you learned in Chapter 8 is used for correlation too, only we articulate the null and alternative research hypotheses differently, and instead of the population mean, we hypothesize about the population relationship. The notation for the population relationship, correlation, is the Greek letter rho, and the symbol is shown on the slide. The basic question for this hypothesis test is whether a correlation exists in the population. The correlation from the sample data will be used to evaluate the hypotheses. When there is a specific prediction about the direction of the correlation, it is possible to do a directional or one-tailed test. For example, if a researcher is predicting a positive relationship, the hypothesis would be that the population correlation would be greater than 0. Open your book to page 581, the critical values for the Pearson correlation table. To use the table, you need to know the sample size, n, and the alpha level, as well as whether you're doing a one-tailed or two-tailed test. At the top of the table are instructions about how to locate and interpret the critical table value. And what the instructions say is that to be considered significant, the Pearson-R you calculate on your sample data must be equal to or greater than the table value to be considered significant. Remember that n in correlation is the number of pairs of scores you have in your sample data, and degrees of freedom, df, is calculated by n minus 2.